Hello student, today we are going to discuss the ring structure of the glucose. On the basis of chemical evidences, stereo structure of glucose was represented by Fischer projection formula. See here the Fischer projection formula. This is the Fischer projection formula of glucose. All the 6 carbon atoms are on the one line and CHO group is present on the carbon atom number 1 and CH2OH is the carbon atom number 6 and all the middle 4 carbon atoms are present in this way. Student, glucose was found to exhibit some more chemical properties and which could not be explained on the basis of this Fischer projection formula. Hence, it is necessary to draw or to write another structure for the glucose to explain all the properties. Ring structure of the glucose fulfills all the properties. Glucose found to be have two cyclic structures. The ring structure is called the Haworth formula and this is called Fischer projection formula. Students, see here, this is the ring structure of the glucose. Here in the ring structure of the glucose, see, this is the carbon atom number 1, this is 2, this is 3rd, this is 4th and this is 5th and this one is 6th. Here ring is formed between the oxygen of carbon atom number 5 and carbon atom number 1 carbon of carbon atom number 5 and the hydrogen, see here, of carbon atom number 5 goes to carbon atom number 1. Here H, OH and this H. This is the ring structure of the glucose. Here this one and this ones are the two hemiacetal structure of the glucose. This is called alpha D or plus glucose. This is called alpha D or plus glucose and this one is called beta D or plus glucose. These two structures are differ only in the configuration at C1 position. The additional chiral center resulting from the ring structure, ring closure. The two ring structure are called alpha and beta anomers of the glucose at C1 is called and C1 is called anomeric carbon. Students, these two ring structures are called alpha and beta anomers. Students, the ring of cyclic structure of glucose contain 5 carbons and 1 oxygen. See here, this carbon atom number 1, 2, 3, 4. 1, 2, 3, 4 and 5 and is 6 one is oxygen. Hence 6-member ring structure is present in glucose, but out of this one is oxygen. It is called pyranose structure. This is called pyranose structure because it is similar or analogy with 6-member heterocyclic compound of pyran. See here, what is the 6-member heterocyclic compound? Here the 6-member heterocyclic compound is in this way. This is 6-member heterocyclic compound of pyran. Students, in pyranose structure, see here, the compound which are present in Fischer projection formula on right hand side are drawn in downward side and the compound which are present in right hand side are drawn in upward side. The downward side is called alpha side and upward side is called beta side. Haworth formula is better way than the Fischer projection formula to represent structure of glucopyranose. Students, in Haworth formula, pyranose ring is considered to be perpendicular with the plane with respect to plane of paper. See here, this ring is perpendicular with respect to plane of paper. The carbon and oxygen in the rings are in place of, see here, the lower side of the ring is called alpha and upper is beta. Students, the alpha anomer and beta anomer of the ring has its anomeric hydroxyl group at C1 on the beta side. See here. The group which appear on the right hand side on the Fischer projection formula are at the downward side in Haworth projection formula. Okay students, this is about the ring structure of the glucose. See here, This is the Haworth formula for the glucopyranose. Here the groups which are appears on the right hand side in Fisher projection formula are appear at the alpha side. See here, these are on the right hand side in Fisher projection formula are on the alpha side, and these groups on the left hand side in Fisher projection formula are on the beta side. These are resemble or similar with pyranose. This is the structure of pyranose. Student, see here, this is the ring structure of the glucose. Here the ring structure contain carbon and one oxygen, hence this is 6-member ring. This 6-member ring of the glucose is called ring structure, and these two ring structure are called alpha and beta ionomers of each other. These ring structures are called alpha and beta. And why the need of this ring structure? Because this Fisher projection formula could not explain all the properties of the glucose. Hence, to explain all the properties of glucose, some more structure is required, and this is called the ring structure or Haworth projection formula. Okay, student, this is about the Fisher projection and Haworth formula of the